if uppercase f is the Laplace transform of little f, lowercase f, if this exists for s positive and a is a constant, then Laplace of ft minus a times ut minus a, this is unit step function, and this is sometimes written as UAT, okay, unit step function at a. That will be Laplace of this product will be e to the negative as times f of s, and uppercase f is just the Laplace transform of little f. Okay, and we know that this function UAT, this is 0 when t is less than a, and this is 1 when t is bigger than or equal to a. Okay, so we're gonna start with the left hand side. We got Laplace of f and u. So here Laplace of f of t minus a u t minus a, from the definition of Laplace transform of any function. So we got 0 to infinity e to the negative st, just the kernel, times this function f of t minus a u t minus a dt. Okay, this kernel, this function dt, but this function is sometimes 0 and sometimes 1. So we need to divide this 0 to infinity into two parts, 0 to a up to a, and then after a to all the way infinity. So 0 to infinity is divided into two domains, 0 to a and a to infinity. In 0 to a, this function, okay, this unit step function is 0, okay, from the definition. So the whole thing is 0. So this is 0 pretty much. Don't even have to write anything. And this is 1 after a and after a. So this is e to the negative st f of t minus a, and this is 1 times 1. Don't have to write dt. Okay, this is 0 when this t is in between 0 and a, and when t is bigger than a, this is 1. Okay, this part is gone. So basically we are left with a to infinity e to the negative st f of t minus a dt. Now somehow we need to get here f of t or some dummy variable, because t is just dummy variable here. T is in between a and infinity. So we can say t minus a, let t minus a be v. Okay, that means what is dt? We can differentiate both sides with respect to t. Okay, so this is 1, a is constant, so 1 equals dv over dt, so dt in this side, so dv. So dv is just 1 dt. Now this integral becomes, and we need to be careful about t. When t equals a, because this is t equals a and t equals infinity, and we are trying to change this integral into new variable v. So when t equals a, what's going to happen? So t equals a means a minus a equals v, so v is 0. So this integral in terms of new variable, because dt, 1 dt is dv, so dt is dv, and f of t minus a is f v, and the lower limit t equals a. When t is a, v is 0, so this is 0 and this is always infinity. And here e to the negative st, and we can find the value of t from here again. Okay, t minus a equals v, that means t equals, move a over, so t equals v plus a. So here, yes, t means v plus a. Okay, let's work on this. So this is 0 to infinity e to the, let's distribute negative s, so negative s v, okay, minus s a, that's times e to the negative s a. So we can do it in this way. Okay, when we distribute and separate into two factors, we get this f of v dv. So this v is just dummy variable, so if we like we can go back to t, and this factor has nothing to do with v, so we can pull this outside. Okay, this can be pulled outside because this integral is with respect to v. So let's pull this outside, e to the negative s a 0 to infinity e to the, this v is dummy variable, so I can write t if I like. Let me write t as t f t dt, or any other variable of your choice. Okay, and when we write in this way, or we could have left v, this is pretty much Laplace of little f. Okay, Laplace of ft. So this whole thing is then e to the negative s a, or as, same thing. Let me write as, and this is Laplace of ft, and which is uppercase f. I mean, this is Laplace of ft, and that is same as uppercase f s. Okay, and this is what we have in the right hand side above, e to the negative as fs. Okay, final.